All right. So there's a couple sort of hints embedded in the question itself that try to reinforce what you need to do anyway. And the first is, it's a fourth degree polynomial and they give you how many zeros? 3. And the reason for that is, what do you know about irrational zeros? They come in conjugate pairs, right? So you have to include with this the conjugate pair of root 6. So here are your 4 zeros. And so if you set this up, f of x is equal to some a value, which we'll get to in a second, but x minus root 6, x minus a negative, so plus root 6, x plus 6, and x minus a 7. Okay, and so here, when you are finding your a value, the way that you can find your a value is you can substitute in a 1 for every x, and you can substitute a negative 1050 for the y. And when you do that, again, you get your solve. Take your 1050, set it equal to, I'm going to type in a times my factors, x minus root 6, close that off, times the factor x plus root 6, close that off, times x plus 6, and then finally x minus 7. I'm going to substitute in, so use the with key, x equals, and I evaluate it at x equals 1, and I'm solving for a. So I'm going to solve for a, close that off. This is going to be my coefficient of negative 5. Okay, and so because of these square roots here, the other possible way that you could enter your forms is in the polynomial form. So this is written as factored form. If I were to write this as a polynomial, what I would then do is I would use the expand command, and I'd enter what I have here. So negative 5 times the quantity x minus root 6. And you could do this before if you wanted to. You evaluate it for x, but x plus root 6, x plus 6, and x minus 7. And close that off, and when I hit expand, this gives me my polynomial form, which I see here is negative 5x to the 4th plus 5x cubed plus 240x squared and then minus 30x minus 1260. So this is my polynomial written in that expanded form.